Let's look at this question, longest consecutive sequence. So what this means is basically you're given a vector and you need to return the length of the longest consecutive elements. In this case it was 1, 2, 3, 4. Okay, so if we talk about brute force solution, then it's pretty straightforward. You look for an element. Let's say you looked at 100 first in this case, and then you look for 100 and plus 101. If that is also present, you look for 102, and so on. I won't be wasting my time in this, but I think the complexity for that solution would be at least n square. So it's a waste of that. So let's look at a better solution. Let's say that what if we sorted this vector? If we sort this vector, this would have been changed to 1, 2, 3, 4, 100, 200. So we can see that 1, 2, 3, 4 were in sequence. Okay, there can also be an example. I'll just write the sorted one. There can also be example in which the answer is something like this. So in this case, the answer would be 3, since it is 1, 2, and 3. So you can remove duplicates at first. From the sorted array, you can remove duplicates. We have already made a video on remove duplicates. Either you can do that, or what you can do is you don't consider the duplicates. I'll write the code and it will make more sense now. So before writing the code, let's declare the variable. So my max length should be my answer, and I'm initializing it with my int min. Okay, and my current length, I'm just taking one element into consideration. That would be 1. Okay, so now, as I said, let's start by sorting the array. So we sort it in ascending order, and we write for we keep on checking whether the current value is previous plus 1. So we go from 1 to n, and we check if my nums of I minus 1 is basically equal to 1. Nums of I is equal to 1 plus nums of I minus 1. Then it means that the previous value was 1 less. So it means that though they are consecutive. If that's the case, we will let's store our previous value in a variable. So previous is stored in a variable. I'll initialize with the first number in my vector, and I'll just check this if this is equal to my previous. Okay, if it is consecutive. If that's the case, then my previous value will be updated to my current value, right? And my count will increase. So my current will be increased by 1. Okay. Now one more case is that, let's say in this example, both I minus 1 and current I are equal. If that's the case, what is happening? Our length is not increasing for sure, since it's the same value, and even our previous value is not increasing. So we wouldn't write that case. A third case is that my nums of I, basically my nums of I is not equal to nums of I minus. So let's say in this case, instead of there was directly a 4. Okay, So now when we came to 1, 2 and 2, we got the result as 2. Now when we came to 4, when nums of I is pointing to 0, 1, 2, 3, when I is pointing to 3, what is my previous value? My previous value is 2. So this if condition is not true for sure. Okay. If my value is if my I minus 1 is not equal to my 1 plus, sorry, if my nums of I is not equal to my num1 plus nums of I minus 1, it means a new sequence is getting started. So I will update my previous to be this value, which is the current value nums of I, and I will write my current to be 1 because it's a new sequence getting started. But before that, we need to check if our previous sequence was that of maxlen or not. So I will update my maxlen. If it's basically the maximum of maxlen and current, if that's the case. Okay. It looks correct to me. Let's return our maxlen. Oh, we are not getting it. Oh, sorry, it should be begin. Okay, n is not declared. N is equal to nums dot size. We are getting incorrect on this. Getting 1, but output is okay. Let's look at our code for this example. If I sort my code, it would be something like 0, 0, then 1, 2, 3, 4, 5, 6, 7, and 8. Okay. Okay, this should be the sorted array for that example too. And our max line is initially my int min, current is 1. I sort my array, so I get this. My previous is 0. Okay, so my previous is 0. N is equal to num size, which is wouldn't matter in this case. I is 1, so I is currently pointing to 0. My nums of I is equal to my, if this condition is true, my previous was 0. No, this is not true. So I check my else if condition. What is my else if condition? Nums of I is not equal to, okay, this condition is true because my nums of I is 0 and my nums of I minus 1 is also 0, but it is not equal to 1. This condition holds true. My maximum is basically 1 and my previous gets updated to 0 and my current is 1 again. Okay, I think I see what the problem is. So let's move forward. So my current is again 1 and my max line got updated to 1. Now I move on to this second index, which is 1. So is this true? Yes, this condition holds true because nums of I is 1 and previous was 0. So 1 is equal to 1. Previous got updated to 1 and my current is updated to 2. And so on. Right. Before everything is executed, I would also update my max length here. Alright. Okay. But yeah, I also recognize this case. Let's look at this example 3. Because here our sorted array is 0, 1, 1 and 2. In this case, the expected answer should be 3, but we are getting 2. Why is that the case? Initially previous is 0, so my nums of I is 1 and this condition holds true. So my current got updated to 2 here and my previous is 1. Okay. Now when we move to this one here, then this condition doesn't hold true, but this condition does, because my nums of I is equal to 1 and this condition is not holding true. So what we can do is we can either include one more else if condition wherein both my values are same, my nums of I and my nums of I minus 1 are same. If that's the case, what do? We don't increase the length of our current consecutive sequence, and we don't even update our previous. So what we do is we basically move to the next sequence. So we'll just write this continue here, and now we are getting all test cases. Now let's try submitting and check if it, okay, we are getting a runtime error. If the array is none, okay, nums.length can also be 0. So if my nums of length is, okay, wait a second, yeah, so my expected output should be 0 in that case. If my n is equal to 0, return 0. Oh, before that only, I think I should have this here. N is declared here. Sorry for the mess, guys, but all these things happen in interview. One thing I didn't do correctly was that I should have read the constraints beforehand. Now let's try submitting it. Okay, we are getting it accepted finally. Cool. So let's discuss the time and space complexity of such a solution. So what we are first sorting, so sort would take n log n complexity, and then we are traversing from 1 to n. So the overall time complexity in this would be n log n plus n. So in total n log n. And what will be the space complexity? We are not using anything extra, so it's of constant space. Now think about it, can we improve on the time complexity? Even in the question they have mentioned that we should write an algorithm which runs in O of n time. So we should not sort it, okay? That is one thing. Another thing is, let's use a data structures. Firstly, our objective is not to have duplicates in that. And when I say not to have duplicates in a data structures, the first thing you should think about is set. So set will take care of my duplicates, okay? It won't add it. Now once we got rid of our duplicates, we will have all the numbers in our set data structures. In the set, my lookup operation in an unordered set is constant time. Okay, so let's say that there is something like this is the array, this is the sorted array. When we push it in set, so we get something like this, right? We know that 0, 1, 2 and 3 are in sequence here. Okay, what we will do is once we are at, let's say, 2, so we will check if is 2 the starting of the sequence. To check that, we will see that if there is a value which exists in our set which is 2 minus 1, which is 1, but 1 does exist, so we will now check if 1 is the starting position. Does a value 1 minus 1 exist in set? 0. Okay, So 0 can be a starting value. Is 0 minus 1 exist on a set? No, it doesn't. So that means that 0 is a start of a sequence. Now we don't know whether this sequence will be the longest or not, but that is how we can keep track of a sequence. So let's get things started. I said that we will have a set here. So unordered set of int type. Let's name it set. For int it nums, I will do set dot insert it. Okay, this will take care of duplicates. Now I need to iterate through my set. So how do we keep track of the first element in our how do we take something out from set? It's simple. We will iterate through our set. So auto it of set, and value will be basically my it. So now we will check if set dot find it is equal to set dot it minus 1 or it, okay, it minus 1 is equals to set dot end. So we are checking if 1 less is the starting, it does exist or not in this map. If it doesn't, then we can say that the starting position, the starting number of the sequence is value itself. Here let me just write value. We shouldn't have even written it in the first place, but okay, never mind. So if value is my current sequence first, so I will have a variable of cnt. I will initialize it with 1 since this is my starting position, and I will again do the same thing. I don't have previous here, right? So my int of previous is equals to my val, and now I will have a while loop here. While set dot find previous plus 1 exists in my set. If it exists, I will first do cnt plus plus, and then I will update my previous to be previous plus 1. Okay, and at the end of it we'll keep track of our max len. Max len will be nothing but max of max len and my count. Okay, so we do that, and that is all which we need to do. In the end we just return max len. Now let's run and see if it runs fine or not. Okay, let's discuss the time complexity of this solution. So since you can see, at first I have this loop which runs n times, and I'm inserting in my set, so it's a big O of n here. And if the set was ordered, if instead of unordered set I took set, then insertion in ordered set is log of n operation. But since we are using unordered, so this is on average constant. So this whole operation takes n, and we are iterating to the set, and again at most we are traveling the whole array. So in total this all would be O of n. So it's of O of n, and since space we are using a set, our space complexity increases by n. Let's submit and check if it runs fine or not. Okay, excellent.